Welcome to this lesson on array processing in C. We've learned that as programs execute, they store data in variables. A variable typically has a data type and a set of operations that you can perform on the variable. A variable normally stores one value. As our programs run, however, there's going to be times where we need to store multiple values, such as all the test scores for students in a class. An array is a data type that allows us to store multiple values of the same type, such as a character string or the student test scores. In C, we can create variables of type int, type float, type char, or even arrays of structures. Let's go ahead and get started. When you declare an array in C, you have to specify the data type that you want to store, such as int, or float, or char, and the number of elements you want to store. In this case, we create an array to store student IDs. Our array has 10 storage locations. We access those locations using an index value. C uses zero-based indexing, which means the first element in our array is at index 0. In this case, our second student would be at index 1, our third student at index 2. You need to understand zero-based indexing because you're always going to start, when you access elements of your array, at the 0 index. If we create an array of 10 student IDs, for example, our student IDs will reside at student ID index 0 through student ID index 9. Let's take a look at how we declare an array. Again, to declare an array, we have to specify the type of data that we want to store, the array name, and the number of elements on our array. In this case, we've declared an array of type int that's going to store student IDs. It's going to store 10 of them. Likewise, we've declared an array called student GPAs of type double that will store 10 arrays. When we create an array, C will allocate the memory to store the number of elements of that type. So in this case, we've just declared the arrays. We've not used them yet, but we're going to use C's size of operator to see the amount of memory in bytes that C is allocated for each array. Let's go ahead and run this program. So as you can see, our student ID is going to reside in memory and take 40 bytes. That's because we have 10 elements of type int, each that requires 4 bytes. Likewise, our student GPAs is going to reside in consecutive memory locations. It's going to take 80 bytes. That's because we have 10 elements, each of which requires 8 bytes of storage. In this case, we've declared an array named scores of type int. It has 5 elements. To store values in each one of the array elements, we simply specify the array name and the index. We put the index within left and right brackets. So our first element of the array is going to have the value 100, our second 97, our third 88, our fourth 92, and our fifth 85. So note that even though we've declared our array as size 5, our first element is always going to be at element 0, zero-based indexing, and our last will always be at an element that's one index location smaller than the size of our array. So in this case, we have an array of 5 elements. Our last element will be at scores sub 4. So this program creates our array of scores, 5 elements, and assigns the values to them. We then use printf to display the values of our array. We start at scores sub 0, our first element, and we end at scores sub 4. When we run this program, we'll see the following output. So as you can see, scores sub 0 has a value 100, that's the value we assigned, and our last array element, scores sub 4, has a value 85. So using our array, we can specify one variable name, scores, and then get to its individual values using our index variable. A common operation you'll perform with arrays is to loop through the array elements. So in this case, we create our array of type int, scores, we assign values to each one of the array elements, and then we use a for loop to loop through the elements. We start at index location 0, and we loop until we've gotten to the last element of our array. So as long as our index is less than 5, the size of our array, we print the value, and then increment to look at the next value. Let's go ahead and run this program. And sure enough, we see our array output. So we've learned that when we declare an array, we have to specify the number of elements the array is going to store. C programmers will often define a constant that specifies the array size. Then we can use that constant name in our array declaration and any loops that want to loop through the array elements. In this case, we've used the #define macro preprocessor directive to create an array size of 5. We then declare our array scores based on the array size, and you can see that our loop is also defined in terms of the array size. When we run this program, we'll see each of our array elements. So using constants for your array size makes it easier to modify your code and makes your code a little more readable. Probably the most common array you'll use in C is a character array. In this case, we've declared an array called name. It's of type char. It's based on our constant array size, so it has 4 elements. We initialize each one of those elements, so name sub 0 is k, name sub 1 is r, name sub 2 is I, name sub 3 is s. We then loop through the array, displaying the corresponding values. When we run this program, we'll see the following output. As you've learned, the C programs typically place a null character at the end of a character string to mark the last character in a string. When we create an array of characters, we'll typically allocate a large buffer, and we'll use the null character to mark where's the last character in that buffer. And so our buffer may be quite larger than our string, but the null character indicates here's how many of those buffer locations we're using. So in this case, I've increased our array size to 5. We need to hold the characters, KRIS, plus we need space for the null character. And so you can see that I've assigned, after our last character in the string, the null. I can now pass this character string to printf, and it knows how many characters to display because it's going to loop through the array until it finds that null character. So when we run this program, we see that printf has successfully displayed our characters. So when you're working with character string arrays, you always need to allocate enough space for your letters that you want to store, plus the null. So with character arrays, we'll commonly search through the array elements until we find that null character. In this case, I've declared my array size of 5. I then initialize my array, and I put the null character following the last character of my string, and then I can loop through my array. So I declare my index variable I, initialize it to 0. That's the first element in my string. As long as that array element is not pointed to null, I loop through and I count the number of characters. And so in this case, when we run this program, it tells us that our string Chris contains 4 characters. That's because most programs won't want to count that null character. It's just marking the end of the string. Now we've learned that to assign values to an array, we specify the specific index locations within the array that we want to assign the values to. So in this case, we're assigning values to scores 0, score sub 1, score sub 2, and so on. Now our program just loops through the array and displays them. C also allows us to initialize our array when we declare it. And so in this case, I'm declaring my array of scores. It's based on the constant, so I've got 5 elements in my array. To initialize it, I use the assignment operator. I put the values I want to assign to the array within left and right braces. And so when I run this program, I see that C has initialized my array elements correctly. So initializing arrays is a fairly common operation that you'll perform, so you'll need to know this syntax. When we work with arrays, we have to keep buffer overflow in the back of our mind. We've learned that the C compiler will allocate enough memory to hold our array. So in this case, we're declaring an array of scores. that's 5 elements long, and we've initialized the array. We then loop through the array displaying its values, but you can see that the program then tries to store a value that scores 6. Well, our array is only large enough to hold 5 values. And so in this case, we're assigning a value to some location of memory that's not associated with our array. We're overwriting something. In some cases, we may just overwrite a variable. In other cases, we may cause our program to crash. So as you're defining and creating arrays, you need to allocate enough memory to hold your values, but then you also need to keep track of how big is my array so you don't write memory beyond the array's memory locations. And so it's important to revisit how C stores character strings. And so this program declares a variable called letter. It's just a variable capable of storing a single value. The program then declares a variable called string that's a character string array. Remember, behind the scenes, the C compiler will append the null character to our string constants. So in this case, the character A only contains the ASCII A, whereas the character string has the ASCII A plus the null. If we use the size of operator, we can actually see how many bytes the C compiler has allocated for each. So in this case, our character variable requires 1 byte of storage, but our character string requires 2, the letter and the null character. So you need to keep the null character in the back of your mind whenever you're working with C strings. The arrays we've created so far are called single dimension arrays. You can think of them as a bunch of columns or a bunch of rows in a single column. C also allows us to declare multiple dimensional arrays. You can think of a multi-dimensional array as a table. When you create a multi-dimensional array, you're still going to use zero-based indexing. You have to specify the row and column that you want to access when you use a multi-dimensional array. Our first value is going to be at row 0, column 0. Our second at row 0, column 1. Our third at row 0, column 2. Let's see how we create a multi-dimensional array. Assume, for example, that we want to create 2 arrays. One's going to contain student IDs, and the second is going to contain the corresponding test scores for those students. So assume that we have 3 tests. Our array declarations become, we're going to create student ID, its type int, based on the number of students. So we're capable of storing 10 students. But for each student, we need to store 3 test scores. So we specify the number of rows and the number of columns. In this case, 10 students and 3 test scores. When we look behind the scenes, C will allocate enough memory to store each. So when we run this program, we can use the size of operator to tell us the number of bytes that C is allocated for each array. So you can see our array of test scores is 3 times as large as our student ID array. That's because we're storing 3 test scores for each student. So as you've learned, C allows us to initialize an array when we declare an array variable. To start, we're declaring our student ID array, and we're assigning it 5 student IDs. Then we want to assign the test scores. So you can see that for our multi-dimensional array, we use 2 sets of braces. Our first row will assign our first student's test scores, our second row, our second student's test scores, and so on. Let's go ahead and see how we access these values. So this program initializes our student ID array and our student test scores. We then display a message, student and test scores. We're going to create a little table. And then for each student, we're going to loop through the array and display the student ID. Then we have an inner loop that's going to display each of the students' test scores. So note the printf statement for displaying the student grades. We have to specify our row and our column. In this case, our row corresponds to our student variable, and our test corresponds to the specific test score. So we're going to loop through 10 students in the outer loop, and then for each student, we're going to loop through 3 3 tests. When we run this program, we should see the following output. And sure enough, we've created a nice formatted table that shows our student IDs and their corresponding test scores. Now when you use multidimensional arrays, you can get pretty crazy. In this case, we're wanting to track employee sales by client over a specific number of years. So we have an array that's going to have the number of years. Then we're going to have clients within that year. And then with each client, we're going to look at their month. And then we're going to look at the sales per day and then the actual number of orders. And so we're creating almost a 5-dimensional array where we've got years, clients, months, days, orders. So you can see that things would get a little crazy. In this case, we've got an assignment operator that shows us that there are 8 orders on 10/12 in the first year for client 1. Now, the C programming language will allow us to create this array, but you can imagine reading a program that manipulates an array that big can get confusing. So using constants and documenting your code becomes critical. Often, after we've created an array, we'll want to pass that array to a function to perform some processing. When we pass an array to a function, we have to specify that we're passing an array. And for our function to be useful, we just want to say, you're getting an array, we don't know the size, but we're going to pass you a second parameter that tells you the size. So you can see within our function showArray, its purpose is just simply to loop through the items in the array. It's receiving a parameter that says you're getting an array of type int. Then we specify a second parameter that tells us the array size. So within that function, we can just loop through the array elements, displaying them. So we're looping from I equals 0, the first element in the array. As long as our index is less than the size of the array, display it. To call the array, we just simply pass the array name and the array size. So when we run this program, we see our array elements. In a similar way, we've defined a function called showString. Its purpose is just simply to loop through the elements of the array until it encounters a null, displaying the characters. You can see that in our declaration of the function, we've got void, it doesn't return a value, the function name, and then we're telling it that you're going to receive a parameter of type char that's an array. So within our code, we can just loop through the elements of the array until we encounter null, displaying the characters. We didn't have to specify the number of items in this array because we know that the last element in the string is going to be marked by the null character. So when we call this program or run this program, we'll see the following output. And sure enough, it displays our 2 character strings. Now the previous program displayed our 2 character strings, but it ran them together, and ideally we'd like to have a space between them. So this program addresses it. It declares our first name, assigns it Chris, the C compiler will append the null character, our last name, Jamesa, assigns it, and C will append the null character, and then we call our function. But look that we're also passing to our function a character string that has the space. So when we run this program, we'll see our strings with a space between them. But let's take a look at that showString, the second one, that has the character string. Now remember that the C compiler treats character strings as an array. So we're able to pass a string constant to our function, and it will just treat it as an array of characters. When you pass a multidimensional array to a function, you have to format it a little bit differently. So in this case, we have our constant definitions. Number of students is 5, number of test scores is 3. We have a function called showScores. It returns a type void, meaning it doesn't return a value. It then receives the array of integers, that's the student ID, and then it gets our multidimensional array, grades. When you pass a multidimensional array to a function, you have to specify the number of columns in the array. So for our student ID, we didn't have to. It's a single dimensional array. But for our grades, because it's a multidimensional array, we can leave the first bracket blank. It doesn't care about the number of rows, but it does care about the number of columns. Then we pass 2 parameters that tell our function the number of rows and the number of columns. And so then our program, or our function, is just going to loop through the elements showing them. Down in our main program, we initialize the student ID array, and then we initialize the student test scores multidimensional array, and we pass them to show scores. When we run our program, we get our formatted output. But let's go back and look at our function definition. We passed a single dimensional array to the function, so we didn't need to specify the number of elements in the array. We just needed to specify that you're getting an array of type int. But for the multidimensional array, you have to specify the number of columns. So in this lesson, we used some functions to perform output on our array, and we did that so you could see how a C program passes an array to a function. In the next lesson, you'll learn that to better manage your code and to improve readability and to increase code reuse, programmers often break larger programs into smaller pieces called functions. Each function should perform a specific task, such as the printf function that displays output on the screen. In this lesson, we used functions to display the values of an array. Here's a simple example of creating a function in C. We've got our header file, standard.io.h. That's because we're using printf, and that's where printf is defined. But we're declaring a function called sayHello. Its purpose is just simply to display the hello world message. With our main program, it calls that function by referencing the function's name. The parentheses that follow the function name specify the parameters we might be passing to the function. We've used parameters with printf to display multiple values. In this case, our function doesn't require any parameters, but we have to include the empty parentheses. So we'll take a big, deep drill down on functions in the next lesson.